So now let's see, this is a homework problem too. Now we are going to give you the discuss these homework problems. So for very large Pauli trials with very small probability of success, the binomial distribution approaches Poisson distribution. Let's do this together. Now, we are having 2-1. Binomial distribution approaches Poisson distribution. Large number of Pauli trials, small probability of success. So if we have, before we get started, it is desirable to have expected value of both distributions match. Okay, so that is lambda equals to NP. So this is the expected value. So what we have here is we have X is binomial, N and P. Now lambda equals to NP, then what is P? P equals to lambda over N. So what is the probability X equals to K for binomial distribution? It's actually N over K. Then you have P, K, 1 minus P, N minus K. So because this is N trials, and you have K successes, right? So that means you have very large number of N trials, and you have K success. What's the probability? So since we are trying to use this, replace P with lambda over N, then derive for the Poisson, then we are going to have N out of K, then lambda over N, K, 1 minus lambda over N, then you have N minus K. So what is this part? Let's expand it. This will be N factorial divided by K factorial, N minus K factorial. And then we have, second one is lambda K over NK. And we have 1 minus lambda N, and this is N divided by 1 minus lambda over N K. So obviously we need lambda K, and we also need K factorial. You see, in the Poisson distribution, we have exponential lambda K and K factorial. So now X equals to K. So we need this lambda K, K factorial, and we also need exponential lambda. So the rest should approximate exponential lambda. So what is that? Let's see. So let's just put these two together. This is lambda K over K factorial. Oh, this part is what we need. Now we also need 1 minus lambda over N, and then power N. We have this part already. Now we need to put this together. So this will be N factorial divided by N power K, N minus K factorial. Then we have 1 minus lambda over N minus K. Okay, now we need to check this part. So this part is one part. We also need to check this part and also this part. Okay? So in the problem statement, we have a very large number of bodily trials with very small probability of success. So for this part, if we have limit n goes to infinity, because we have a large number of trials, so then we have 1 minus lambda over n power n. This is actually the exponential minus lambda, because exponential x is actually the limit is n goes to infinity 1 plus x over n power n, okay? And exponential minus x is actually equals to limit n goes to infinity 1 minus x over n, then power n. So here we just replace x with lambda. So this is the limit of exponential minus x. So problem solved. We have this part is actually, this part is exponential minus lambda. Just replace this part. Now, so far we have these two, and now this one should approximately equals to 1. This one should be approximately equals to 1 too, right? Then we prove this. So now let's have a look at the first one. Now for fixed 0 less than k less than n, so n over n power k, n factorial, and then n minus k factorial. So this is actually equals to n times n minus 1, n times until you have n minus k plus 1, because you want to cancel part of it with n minus k, right? So divided by n times n times n, and then times n, how many? K terms. So this will equals to 1 times 1 minus 1 over n, then times 1 minus actually k minus 1 over n. Okay. So in this way, if n is really big, so this will, so if we have limit n goes to infinity, n factorial divided by nk, n minus k factorial equals to this one. This is approximately equals to, and also this one should be limit n goes to infinity. Then we have directly equals to 1. So this part equals to 1. Now let's see the next part. N goes to infinity 1 minus lambda over n, and then we have minus k. So lambda is constant, okay, and it's and this is small, not infinitely large, right? So n is very large. So this part is when n goes to infinity, this part goes to 0. So we have 1 here. So this part equals to 1. So therefore we get limit n goes to infinity, probability x equals to k is actually equals to the Poisson lambda k over k factorial exponential minus lambda. And this is Poisson.